Okay, so here we are in Unity. What we're going to do is straight away get into creating our optimized shader. So first thing, we're going to duplicate our emit map capsule here, and I'm going to rename this one here to be 9_optimized. We're going to duplicate our last material and shader, and we're going to rename these to be 9_optimized. Okay, that's great. So if we open up this in MonoDevelop, we can get ahead and start editing it. So I'm going to call this 9-optimized, and I'm also going to change this bump depth to be a range of 0 to 1, which will just make it a little bit more control. I'm going to remove the second pass. This will just make it a little more easier to work with. We can save that, reload, and we can find it in our list. Okay, that's cool. So that's working just as we like. Now you notice that it doesn't have the red light affecting it at the moment, and this is simply because we have not loaded in 2 passes. We're just working with 1 pass for now. Okay, that's great. So let's go ahead and start manipulating this to be more optimized. So before I go through and change all of the floats to fixed and stuff like that, we are going to focus on what we can optimize between the fragment, vertex, and object spaces of the function. Okay, so the first thing that I want to do is I want to take all of this calculation here, calculating our view direction and light direction and attenuation, and move that to the vertex function. We do not need that in the fragment function. So I'll just paste this in here. So we have our view direction, and we have pos world here. So I'm just going to change pos world to be a float 3, actually this will be a float 4 pos world, and I'll just change that there, pos world, light direction, attenuation, and we have our ones down here. So what I want to do is I want to do a bit of a lerp here. So we'll go float 10 equals lerp, and we'll lerp between A and B based on a blend value. So this is how a lerp works. It's just a blend, so we can blend between 2 different values. So our value is of course going to be world space light pos0.w. That's going to be our blend. And now A, if it is 0, attenuation is going to be 1.0. Now if it is B, it's going to be 1 divided by distance. Now we haven't got distance yet, so we'll need to grab these 2, copy them, and I'll paste them up here. Alright, so now that we have these, we can create the other lerp. So the other lerp, this one here is going to be a float 3, light direction, and we are going to lerp between the normalized, actually because both of these are going to be normalized, we'll just put the normalize outside of our lerp, which will just make it a little more optimized, and we will lerp between our world space light pos 0, if it is 0, and the fragment to light source, which is defined up here. So we can now remove all of this, and we have these 2 lerps, and we have this one here. So i.posWorld, this is actually just going to be posWorld, and we have that, which is fantastic. So we need to return this, return the attenuation and the light direction to get into the fragment shader. So we can now change posWorld, light direction, because we no longer need posWorld in the fragment shader. And this will be a float 4 because we want to put the float 3 light direction and the attenuation inside it. So I'll just come here and I'll go o.light direction equals float 4, and we'll have light direction, comma, 10. That's great, so we can now return that there. Fantastic. Alright, so with that, we now need to edit our fragment shader so we can test this and make sure we haven't broken it. So we just need to change our light direction, our attenuation at the moment. So coming down here, we can see attenuation here. This one here, I'm going to change this to be i.lightDirection.w, and we'd use that for all instances of attenuation. So this is the only instance of attenuation here, so we don't need to do it anywhere else. We do need to, however, go i.lightDirection.xyz and do that for all of the light directions here, which is 1, 2, and 3. I think that is it. Okay, so I'm just going to give this a go, and it'll probably turn pink. Yep, there we go. So this means that we have an error. Okay, so our error here is redefinition of light direction, or declaration of light direction conflicts with previous declaration. So this is nice and easy to fix. And you can see we have float 3 light direction and float 3 light direction. So we can't have 2 of those. So I'll remove that, save, reload, and there's still another error, which is fine. So you just need to go through and find the next error. Okay, so our error looks like it's going to be at line 107 or 110. So back into our shader here, scroll down, you can see here light direction.xyz, normal direction, view direction, undefined variable view direction. Okay, so you can see here that I also took the view direction and I put this into our vertex shader here. So we need to grab this here. So I'm going to grab the view direction and I'm just going to reinitiate these so they're in order. Okay, that's great. And I'll make this o.viewDirection. And we come down here to where we have view direction, and I'm just going to go i.viewDirection. We'll do that for every instance of view direction, which is just the one. Reload that. More errors. You do get a lot of errors when you are writing shaders. Assignment of incompatible types at line 70. So go to line 70. Okay, so view direction. This one here, we are doing a float 3 and we're assigning it to a float 4. So we need to make sure that that is in fact a float 3. Reload, more errors, undeclared identifier view direction. So this one here is going to be at line 17 Noob. So where it says GLSL vertex shader or D3D11 or D3D11-9X, these are not the errors you want. You want to come down to these ones here where we have undefined variable view direction at line 111, which is nice and easy. View direction, we'll go i.viewDirection. Reload, and it looks like it is now working. Okay, so it isn't now working. So it's a bit of a pain. You often get that when you are optimizing your shaders, replacing a whole block of code. You get a bunch of stuff that doesn't work, and it's just bits that you have forgotten to replace. Okay, so we're still flowing along here. Let's go through and see where we can optimize this further. Okay, so the next thing I want to tackle is these dot products, where we have our lighting. I want to create a new one here. I'm just going to go dot product float in dot l equals this saturate function. So this one here is used a lot in our shader, so we're just going to replace every instance of this with in dot l. So you can see we have that one there, which is the dot of the normal against the light. And if we go through, we have here the normal against the negative light. We have the view, so I'll ignore that one, normal against the light, so this one here. So I'll go in dot l, and that is it. So we'll just reload this. Alright, so I've broken it again, expecting a bracket there, so this is at 114 or 115. So I'm coming through here, we can see 1 minus, we can actually come through and remove this. So we grab this one here and we'll go 1 minus n dot l, and we have 1, 2, okay, so we have one extra one here. That was the error. That's now working, which is great. Okay, so back into our shade here. We've now optimized that, and we're not really going to get this much more optimized at this stage. So we can go up and see what we have. Okay, so our light direction here. First thing I think I might do is we might just see if we can place this attenuation and this light direction inside here. And that way we don't have to store the variables. So I'll just tab this out, and we want to have the light direction first. So we'll copy this, copy, comma, enter, and then we'll grab the attenuation. Okay, that's great. And we'll just remove these two lines. So that there is now in this one function. Reload that, that worked fine. Okay, so now that we have this, we can go through and continue optimizing. As you can see, there is a lot of optimizing that we can do, and this is just, it's very easy, it just takes a little while to do. First thing I'm going to see is, I'm going to see if we can start rendering for Flash. Reload that, and yeah, it does. It looks like we can already start rendering for Flash, and we haven't actually done too much. Alright, that is fantastic. Let's go through and start correcting some of these variables. So you can see here we have a lot of floats, and we really want to change those floats to be something more like fixed or half. Okay, so these floats here, I'm going to change these to a half. Remember, we can use half and fixed. Half is for anything that is beyond the values of 2. So just go through, go half, half, half. This one here can be fixed. because it's a color, it's going to be between -2 and 2. Okay, so our bump depth is going to be fixed, our emit strength is going to be a fixed, and you can see our shininess and our rim power, they can be a half because they go beyond 2. Alright, our light color can also be a half, and this is because our lights, although it is a color, it often goes beyond the value of 2 because we get some really intense lights. So we'll save that, reload that in Unity, and it is working fine. Let's move on. Okay, so let's go to these, where we can now grab a half for all of these, and we'll do the same down here. Half light direction, we want to grab the half view direction, and our normal world, these can be a fixed. Okay, that's great. Now view direction, I just want to check this, it is in fact normalized, so I will paste that in, reload that, and just make sure it's still working. Often when you're changing these, you'll find you've changed something and it breaks your shader, and it's important to make sure you don't do that. Okay, so we have our model function here, multiplying this. Okay, so we'll paste this in here, and just coming down the list we have a pos world, this one here can be a half. Okay, so we're just using that there and there. Now the reason we don't just copy and paste this piece in is because we're using it twice, we don't want to calculate it twice. Alright, fragment to light source, this can be a half. Distance can be a half. Okay, so the distance here, we can probably actually grab this distance and just go 1 divided by that. Just remove that extra calculation. Okay, so if we reload that, it is working. And yeah, so we now have a much more bulkier line down here. We've got a lot going on in it, but we have less variables being stored. Okay, so this one here is in fact going to be a half 4. Reason it is a half is because we have our, actually we can have this as a fixed, now that I think about it, because this loop is going to loop between 1 and 1 over our distance, which is going to be at a maximum of 1 and a minimum of 0. Okay, so that means that our light direction here can in fact be a fixed. We'll reload that, still working. That is fantastic. Let's go down and move to our fragment function. Let's start by returning a fixed for frag. We can't see any values greater than 1, so we can just go ahead and return a fixed, and that will work fine. Alright, so these text 2Ds, once we've unwrapped them, they can just be fixed. So we'll fix that, and we reload it. That's working fine. Okay, so we'll go down to the local chords here. I'm going to squish that local chord Z straight into that same function, so we can remove that. This one here you can see is 2 times textn.ag minus float2, so this can in fact be a fixed. Okay, so we'll reload this, still working, and that is great. Okay, so moving down to this normal direction here, this is normalized, which means we can do a fixed. This n.l, we can do a fixed for that. Specular reflection, now this one here can become greater than 1, but we can't see it, so we can just go ahead and make these a fixed. Okay, so this one here can also be a fixed. Rim lighting can be a fixed. Light final can be a fixed. Okay, so we do all that, reload, and that works fine. Last one here is that we have is our normal transpose matrix. This one here is a float 3x3. Now I believe we can in fact make this a half 3x3. Yep, we can. There we go. So you can have a half 3x3 matrix. Now you might also be able to do a fixed, but although the function does exist, it may not work. So it is working, but I'm not sure whether I would want to keep with it. Yeah, it's working fine on this model. However, I'm going to leave that a half. Or did we? No, we have normalized it all up there, so we can leave that as a fix for now. Okay, that's great. So that is an optimized shader. That was easy. Okay, so last bit we need to do is we need to copy this pass, and on the second pass we need to make sure this is set to forward add blend 1:1. We will remove the color tint, texture, the ambient light from our shader. We'll also remove any emission. We will leave in the specular there, and we'll take away that emission, the emit map. Reload that, and that is working fine. Okay, that is great. Okay, so that there concludes this lesson. So I hope you guys learned something. I hope you guys enjoyed this. It's been great teaching you guys. I was really looking forward to making this series, and I hope you guys were looking forward to following it. If you have any questions at all, by all means leave a comment underneath this video on unitycookie.com, and I will do my best to get back to you and help you out as much as I can. So that's it for this beginner series. After this series we will be looking into the intermediate series. We'll be covering some more stuff to expand on our knowledge from the beginner series. So that's all for today. My name is Alex Tilford and you are on unitycookie.com.